Hi, my name is Darshan and I'm an online tutor of math and physics. This is the last question, FRQ 5 of AP Physics 1 2023. Uh, this says that a rod with a sphere attached to one of the end of a horizontally mounted axle and carefully balanced so that it rests in a position vertically upward on the axle. So here we have the axle and there we have a rod. A sphere is massed on the top of it and it's carefully balanced so that it's just resting, vertically like this or like this. Now they are saying that the center of mass of the rod sphere system is indicated with a cross. So this is the center of mass. And the sphere is lightly tapped, so just a push is given to this sphere like this so that it just goes down, of course. And the rod sphere system rotates clockwise with a negligible friction about the axle due to a gravitational force. All right, a student takes a video of the rod rotating from the vertically upward position to the vertically downward position. While the figure 2 shows 5 names, still shots that the student selected from the video. So, the student made a video and took some stills at the 5 different positions. These frames are not equally spaced apart in time, that's fine. So, these are the 5 scenarios. Use the frames of the video shown in this figure. In which frame is the angular acceleration of the rod sphere system the greatest? Justify your answer. You're talking about angular acceleration. So angular acceleration means we need to talk about the torque. Okay, torque is nothing but R cross F. We very well know that. Now R remains same, right? Whatever is the distance between the center of mass and the axle, it remains same in all the positions, right? So this is the value of this is the value over here. This distance is R and it points like this, and this is R here, R is here, R is here, R is here, R is here. So that's same in all the 5 cases. And the value of F is also same, right? Because its mass, whatever it is, it's not given, right? So let's say the mass is M. So mgx downwards here, mgx here, mgx here. In all the 5 situations, mg is constant. So the force is constant. So only thing which changes, we know that cross product is just sine of that angle. Only thing which changes, the only variable is the theta. And we want to maximize the angular acceleration. So in other words, obviously we want to maximize the torque, because more is the torque, more is the alpha, because the mass is anyway not changing. And what is the maximum angle here? It's pretty intuitive. It's 90 degree right over here. Otherwise, other angles are either acute or obtuse. It doesn't really matter because sine is maximum when the angle is 90 degree right. So sine 90 is maximum, and this is in situation number C. So at C, we will have the maximum torque and maximum alpha at C, as angle is 90 degree and sine 90 is 1, which is the maximum value, right? In the next question, in which frame is the rotational kinetic energy of the rod sphere system the greatest? Briefly describe. Okay, so the rod energy, okay, let me just take I think I'm going to need this image on the next one as well. So what I'm going to say is that whenever we talk about rotational kinetic energy, and remember in this case there's no friction and all, so the energy is very well conserved. So if the energy is conserved, can we say that, and remember the system starts from rest, so initial kinetic energy is 0. So can we say that the situation in which there is a maximum decrease in the potential will result in a maximum increase in the kinetic? Because we know that let's take the reference as this point, as the center, right? So I'm taking my reference as the axle. This is the reference. Obviously the initial energy is mgh, whatever this height is. We do not know. Let's say the height is h. Now I'm saying that if we conserve the energy, and here the kinetic energy is 0, So can we say that the total energy is actually mgh at such frame number A, which is the total energy? And when will the kinetic energy be maximum? When the potential energy is minimum now, which is in frame E, because in frame E the potential energy is minus mgh and the remaining energy will be kinetic. So obviously this kinetic will come out to be 2 mgh, which is the maximum in this case. Why maximum? Because in all these situations the potential is not going to a minimum value. It is some value more than the minimum possible value. So obviously the less change in potential will increase the kinetic with a less amount. That makes perfect sense. And more decrease in the potential will increase the kinetic energy by a greater amount. It's like the energy bars, if you remember. So the energy bar works like in situation number A, this is the complete potential and the kinetic is 0. And in situation number C, the potential is just negative of that value. So obviously kinetic should be maximum at this point because the sum of both the bars is constant, right? So that way is also it makes a perfect sense. So answer is frame number E because of minimum potential energy. All right. Okay, some dimensions are given to us, that the center of mass is given to us as 3L/4 distance from the center. The rod sphere system has a mass m and L and the center of mass is 3/4 at L. Derive an expression for the change in kinetic energy of the rod, sphere, earth system from the moment shown in figure A to the moment shown in figure E. We just did that, right? Except for the fact that we didn't take this h into length into account. So all we have to do is go back, borrow this expression because that is eventually the change in the kinetic energy, because the kinetic energy at A plus potential energy at A is kinetic energy at E plus the potential energy at E. Kinetic energy at A is 0. Potential energy at A was mgh, like we said earlier. Kinetic energy at E is something which we need to find, and the potential energy at E is minus mgh. So the so adding mgh both the sides, 2 mgh is equal to the kinetic energy at E. This means that the kinetic energy at E, which is as good as the change in kinetic energy, because the change is Ke minus Ka and Ka is 0. If it is confusing to you this way, I will not replace Ka with 0. I will keep it as it is, and I will then move Ka over on the other side, so that now we are on the same page, that 2 mgh is equal to delta K. So the value of delta K will be 2 mg, and the value of h is 3L/4 because that is the center of mass height. So the answer is 3 mgl, 3/2 mgl. That is the change in the kinetic energy. Pretty straightforward, right? All right. The last question which we have is, briefly explain why the rod and sphere gain kinetic energy even if Earth is not included in the system. Okay, so mg is still acting, right? Mg is still acting, but now mg will be considered as an external force because Earth is not a part of the system. So we cannot say that the potential energy is mgh. Mg is just an external force. It's no longer an internal force. However, notice the work energy theorem, if you remember. Work done by all the forces is change in kinetic energy. Now mg is an external force and mg is, let me borrow this image once again. Okay, now mg is an external force and mg is acting down like this continuously. And if you can help me, where is the displacement? Displacement is also down, right? Obviously some components and all are to be taken, but the force of mg is down, displacement is down. So the angle between the force and the displacement is acute, which means that the work done is positive. because the work done is given by F dot D. Force and distance or displacement are in the same direction. It means that the work done has to be positive. So can I say that the work done by all the forces, and basically all the forces is just the gravitation force because that's an external force, is positive with this, with what I just justified? And if it is positive, can we say that this is positive and this is equal to the change in kinetic energy? And if the change in kinetic energy is positive, it definitely means that the final energy is more than the initial energy. Then only the change can be positive, and hence this justifies the fact that then also, even though you won't consider the earth as a system, the rod and the sphere will gain the kinetic energy as it moves down, because the change in kinetic energy is positive as the work done by the gravity is positive. Right, this was the last part of the last question. I hope it makes sense. I have made videos for all the 5 questions of AP Physics 1 2023 FRQs. Please check. Let me know if you feel like I have messed up somewhere or your thought process is different, you have done differently in your exam. Please post it down in the comment section. I'll try my best to answer. Thank you very much.